Hi, I am Victor. Last time we saw that a big enough neural network can approximate any function. The challenge is finding the right weights and biases. These parameters are what the network learns. The difference between prediction and reality is called loss. Our goal is simple: minimize it. A real network has millions of parameters in space. Since we can't visualize that, we'll group everything into just weights and biases and let the z-axis represent the loss. For any parameter set, we get one loss value. For all possible parameter sets, we'd get a loss surface. The lowest point means the best parameters. But here's the catch: we don't know the whole surface, and calculating every point would take forever. All we can do is measure the loss at a few specific parameter values and guess what might be in between. Finding minimum under these circumstances seems impossible, but Newton gave us a shortcut. He had faced a similar issue while trying to describe motion at any and every instant, not just step by step. He imagined taking 2 points on a curve, bringing them closer and closer together. As the distance shrinks, we get the tangent, which is the instantaneous slope, the rate of change at that exact point. By making the change in x very small and using some clever math tricks, he built a formula for rate of change for any instant. We do the same with the loss function. Keeping all but one parameters fixed, we find the slope and it tells us which way loss decreases. Do this for every parameter and we get the direction of steepest descent. So we can't know the exact address for minimum loss, but we can keep heading in the right direction. But direction isn't enough. We also need to know how far to step. If the steps are too big, we overshoot and make things worse. If steps are too small, progress is slow. And when slope itself is small, the steps naturally shrink even more. So we adjust large steps when the slope is steep, smaller steps as it flattens. Eventually the slope approaches zero, updates shrink, and we settle into a minimum. That's gradient descent, the process of rolling downhill until loss is very low.